All right, for number 7, we're going to have to solve this equation by factoring. So for number 7, before I factor it out, I can see that each of those equations is equal to 0. So this is exactly what I have to do for number 7 as well. So to do it, I'm going to move my term to the other side of the equation by doing inverse operation, which is adding 12x to both sides. This equation becomes then 6x squared. I will go with the x term in the middle and then minus 90 as the constant equal to 0. Now, in order for me to factor it out and put it in this possible form, to make my life a little easier, I'm going to factor out the greatest common factor. So the biggest number that divides 6, 12, and negative 90 evenly. In this case, it is 6. Okay, so if I divide each of those terms by 6, I'm going to end up with x squared plus 2x minus 15. And don't hesitate to take that moment to double check. So 6 times x squared is 6x squared, 6 times 2x is 12x, and 6 times negative 15 is negative 90. Now, I'm going to keep on going, and I want to represent this expression as the product of two binomials. So to do it, I'm going to use a diamond problem. Up here, I'm going to write the product of the coefficient of the x squared term, which is 1, and a constant, which is negative 15. So 1 times negative 15 is negative 15, and the middle term, the sum term, is the x term. So I'm going to use only the coefficient of 2. And again, I'm using only the coefficients because it helps me skip that extra step. Otherwise, if you're choosing to use the variables, you're going to have to generate the generic rectangle. And from the generic rectangle, you'll be able to write your binomials. So now I'm thinking of two numbers that when I multiply it will give me negative 15, but when I add them together will give me 2. Well, I know that 3 times 5 is 15, but then I have to adjust the signs. I need the sum that is positive, so I know that 5 has to be a positive. So negative 3 times 5 is negative 15. Negative 3 plus 5 is positive 2. Now, because the coefficient of x squared term is a 1, I'm able to write my first term of each of the binomials as x. X times x is x squared. And I'm going to use the numbers that I have found and literally transfer them into that expression. This is negative 3, so I'm going to rewrite it as x minus 3. Positive 5 will be rewritten as x plus 5. Now I'm not, so I have completely factored out the expression, but the instruction was to solve for x. So if I set each of the equations equal to 0, the one way that I'm going to get 0 in this binomial is if x equals to positive 3, because 3 minus 3 is 0, and in this case, if x is equal to negative 5, because negative 5 plus 5 is 0. I do not worry about the 6, because if this comes out to be 0, any number times 0 is 0. I have used the 6 and kept the 6 to help me factor out the greatest common factor so that I deal with smaller numbers and so that I'm able to use that simpler version of diamond problem. That's all.